All right, so let's go ahead and finish this problem out. We are going to we're going to start with this equation here for KCL. So for I1, I could very easily just write Vs minus Vx, right? The voltage drop across that 500 ohm impedance, and I could divide by the impedance, which in this case is 500 ohms. And I can say that that current I1 is equal to the sum of I2 minus or plus I3, which in this case I2 is just going to be Vx minus 0, because this line down here is my 0 volt. I guess I haven't been drawing ground really, but I could. In AC circuits, typically ground isn't drawn. It's usually the neutral line, and we don't want to confuse those, but you can treat this bottom leg of the source as ground for math purposes, or as 0 volts at least. So Vx minus 0 divided by ZC1, which in this case we know is minus J1591.5. And then we want to do our last piece here, which is going to be I3, which is Vx minus 0 again, right? The voltage. So I did the voltage across this divided by the resistance, the voltage across this one, and now I'm doing the voltage across this one. In this case, it's just going to be 200 ohms, right? And so now all I have to do is solve for Vx, okay? So let's go ahead and do that. So I've got, basically I can pull a Vx out of the right-hand side. So I got Vs over 500 minus Vx over 500 on the left, which is equal to Vx times basically minus J on the bottom. I'll just write this as minus 1 over J 1591.5 plus 1 over 200, right? And let's see here. Okay, so now we have Vx there. I can add the Vx over 500 to the other side. I get Vs over 500 is going to be equal to another Vx term, so I can factor that Vx out. And I get minus 1 over J 1591.5 plus 1 over 200 plus 1 over 500, right? And now I can multiply both sides by 500. So I would get Vs is equal to Vx times minus 500 over J 1591.5 plus 500 over 200, which is 2.5. Right? Yep. And then plus 1, so 3.5 right here. All right. So I'm almost done with this problem. I basically just need to convert this now into a complex number, and then I can find the phasor value for this piece right here. And once I find that phasor, I can divide Vs divided by that phasor, and I'll get my phasor for Vx. We can convert to the time domain, and then we'll be done with this problem. So let's go ahead and do that. Again, a J on the bottom just becomes a minus J on the top. So I can rewrite this as Vs is equal to Vx times 3.5 plus, right, because the minus J and the J are going to become, or the minus J and this minus sign are going to become a positive J. And then let me just write what is 500 divided by 1591.5. It's going to be 0.314. So it's going to be J 0.314. All right, and now I can write this as a phasor by doing 3.5 squared plus 0.314 squared, square root. That's going to be my R. I might run out of space here and need another slide. Let's do that. Squared plus 3.5 squared, square root. I get 3.514. And then for phi, I'm going to get tan inverse of 0.314 over 3.5, which in this case, that's going to give me 5.126 degrees. Oops. Okay, so we've got our R, we've got our phi. That means that we know this phasor here, this one. Let me just go ahead and add a new slide. Let's see, add a page. How do I add a page? Add a page here. We'll go here. I guess I can just make it another slide that looks like this. And then let's come back here and copy the two values that I just found for the phasor. And let's also grab this equation. Oh, I grabbed some extra stuff. That's okay. Just going to wrap this problem up real quick mathematically. All right, so Vs is then equal to Vx times 3.514 angle 5.126 degrees. And then I know that my Vs phasor was just 80 angle 0. So I can write 80 angle 0 degrees divided by 3.514 angle 5.126 degrees is going to give me Vx, which in this case is going to be 80 divided by 3.514, 22.76, or 77 if you want, angle negative 5.126 degrees volts. That right there is my phasor for Vx. Of course, I need to write this in the time domain, so I can just write Vx of t is equal to 22.77 times the sine of omega t minus 5.126 degrees volts. All right, so that is my Vx of t from this problem. I hope that you're starting to see kind of the patterns here. We just need to get two things into the same form, specifically into phasor form, so that we can do very easy division or multiplication depending on the problem. And then once we get the phasor, it's very trivial to figure out the time domain expression. Okay, so I'm gonna go ahead and stop this video here. I think this one's also pretty long, but I'm gonna stop it here. And then in the next video, we're gonna get back into a review of nodal analysis.